I'll just preparing for the live stream.
Yeah, message is coming.
Okay, Sapna.
Okay, thank you, ma'am. So, good evening and welcome, everyone. It's my pleasure and honor to welcome you all in Indian Association of Physics Teachers PER lecture series. IAPT is dedicated to fostering excellence in the teaching and learning of physics and is committed to advancing the field of physics education and supporting educators in their professional growth. I'm sure that the knowledge and ideas shared at this platform will inspire and equip us all to make a positive impact in our classrooms. So I would like to extend a warm welcome to our esteemed president of IAPT, Professor P.K. Ahluwalia, whose support and leadership have been instrumental in our efforts. A special welcome also goes to Ma'am Rekha Ghorpade, the Secretary of IAPT, whose dedication and support continue to drive our mission forward. I welcome our distinguished speaker, Dr. Deepa Chari, Faculty Homi Bhabha Center for Science Education at DCSC. The title of her talk is Encouraging Responsive Practices in Science and Mathematics Teaching. We are fortunate to have you, Dr. Deepa, and please join me in extending a warm welcome to her. We look forward to a stimulating and enriching session. I would also like to welcome all the dignitaries and participants joining us today. Your presence is greatly valued. So I would like to request Ma'am Rekha Ghorpade to please chair the session. Ma'am Ghorpade is a former head and associate professor of physics, RJ College, Mumbai, and currently she is serving as General Secretary of IAPT. So before I hand over the mic to Ma'am Rekha Ghorpade, I would like to invite Professor Ahluwalia for his opening remarks.
Thank you. I'm very happy that we are having another very good session. And I welcome everyone here in this program, especially our distinguished speaker, Professor Deepa Chari, and the chair of today's session, Professor Rekha Ghorpade. And I'm very happy that we have very distinguished senior life members of IAPT present today. Professor J. Sethuraman, welcome. I am also very happy that this talk is specially targeted to schools and the school teachers. And I think we have that agenda in our IAPT programs, that schools are the biggest stakeholders for us in IAPT. The maximum number of students who are studying physics are in schools. So if we can really reach out to them through these programs, and I think this talk, because it is available on the YouTube also, I think it will definitely reach out. Don't worry about that. The number of the members present today is less, but that hardly matters because the message goes quite far. So once again, I thank Sapna for coordinating this effort. It has run for more than a year, you know. This is something to celebrate. This is the 16th lecture now, so 1.25. We have crossed that. And I'm really happy that we have been able to keep our enthusiasm for physics education research. Also, I would like to tell you that we have also now a regular column coming in IAPT Bulletin on the physics education research advances in that and the latest what is happening in that. We are thankful to Dr. K.K. Mashood for doing all that effort and bringing very interesting research to the IAPT audience. So once again, I thank you all. And thank you, Ma'am Rekha, for chairing this session.
Thank you, sir. So now I'm hand over the mic to Ma'am Rekha.
Thank you, Sapna, and good evening, all. Namaste. I'm really thankful for giving me this opportunity to interact with you all. Respected Professor Ahluwalia, President IAPT, respected veteran IAPT, and we have with us today J. Seturaman and the other honorable members present here. I'm extremely proud and happy to be with you all for this particular 16th lecture of under the PER IAPT PER series. I think it is a very incredible work that has been put in from IAPT and by a coordinator, Dr. Sapna Sharma. I congratulate her and also appreciate her efforts in bringing. We also have a very strong motivating force who is working in the field of PER, who has guided many teachers, many PhD students, and done a lot of work in the field of PER. Is our president, Professor Ahluwalia. I think he is the most inspirational figure in IAPT as a president and as a teacher also. And this is the spirit which is keeping us moving on and doing this kind of a programs. I'm extremely happy to see Deepa here. I have been meeting Deepa quite for some time in HBCSE, but had never had an opportunity to interact with her in her field what she is working. And today is the opportunity that we all will listen to her and we will get first-hand information what she's doing in the field of physics education research. And I'm sure this is going to be really helpful to all of us as the teachers. Let me talk a few things about Deepa. Deepa Chari is a distinguished professor affiliated with the Homi Bhabha Center for Science Education, TFR, in Mumbai. She is recognized for a significant contribution to science education, particularly in the development of innovative teaching methodologies and curriculum design. At HBCSE, her work encompasses research, the creation of educational materials, and the facilitation of workshops for the educators, as well as participation in the policy discussions aimed at improving science education across various levels. Deepa has earned her PhD in physics from Dublin Technological University in Ireland and has over 4 years of postdoctoral research experience at both Florida International University and Kansas State University in USA. Her research has been published in esteemed national and international journals, and we are really excited to have her with us today and look forward to her insights and expertise. So, welcome once again, Deepa, and I request you to take the audience.
All right.
Thank you very much. And
Okay, thank you. Thanks a lot. And let me share my slides. But while I do that, I would just give me a second. What is my screen visible?
It has, yeah, we can see it.
Okay.
Few things.
Yeah.
It's just not giving me the way to change it, so I'm adjusting that. Okay, yeah, all set. So is my slide visible to everyone?
Yes.
Okay, all right. Thank you. Particularly thank you, Professor Ahluwalia, Dr. Sapna Sharma, and Dr. Rekha Gorpade ma'am for giving me this opportunity. There have been several informal communication that we had over several years, as everyone pointed out, and they all have encouraged me time to time to to discuss my some of my work that I do, particularly in school and college communities with teachers as well as physics students. But that is not the only thing that I do at HBCSE. So if you are also interested in gender in physics, to know more about STEM identity research, those are also some areas, also inclusivity in terms of gender, particularly in higher education and at professional roles in physics. So those are the areas that I also am interested in. And if you would like to know more about what I do in those areas, then we can extend this conversation also later. What I'm particularly talking about today is, however, as already Rekha ma'am have pointed out, is more focused at college level and at school level, because the programs that I'm currently dealing with has a lot of participation of students at school and college level who are interested in taking science and who are learning already science and mathematics, and are also probably interested in taking up science and mathematics career. So what I would like to mention or kind of declare beforehand is my talk is mostly structured as a review talk. So I'm taking liberty of using some examples that are probably used by that are brought in by the community members through papers, through some talks, and but many of them are also derived or have also come through classroom interactions that we had through several programs. And me or my colleagues have brought these examples because they all believe that these are good set of anecdotes or examples that we could discuss on different forums, and that would create enough interest about responsive teaching and responsive methodologies in general. And so I'm not particularly talking about a study, but I am rather talking about a particular approach and bringing a variety of examples from college level and from school level, and also from different student and teacher population to make my point more explicit to the audience. And though, like as I said, that most of these examples are at college and high school level, and I see that the current audience that are listening probably are from are mostly dealing with teaching at undergraduate level. But I would say that as a research methodology, this holds good for all across all levels. The little bit nitty-gritties might be different. But these examples kind of like makes the point about how this practice of responsiveness is important and is an important attribute to be built as your professional identity of as physics teacher. And I hope I will be able to do a good justice for that. And lastly, I would also say that many of these examples are still talking or taken from a program called Vigyan Pratibha, which is particularly targeted at nurturing students' interest in science and mathematics teaching and learning at high school level. So it aims the teacher bodies associated with students at high school level and the students, and multiple aspects of that program are kind of like embedded with this responsive pedagogy. So I hope I kind of like gave a broad premise to know where all these examples are drawn, and their originality doesn't matter, but like the context is very close to to our day-to-day interactions with students. So I think that genuineness in it really makes the talk more interesting. So to begin with, this is a quote about discipline-based education research. And what the quote signifies that discipline-based education research has a deeper grounding in disciplinary priorities in the world views, knowledge, and practices. A simple way of probably describing this quote is physics as a discipline has bodies of disciplinary content and practices that physicists believe and prioritizes when they are studying or researching or probably doing some physics related work. Similarly, the culture of physics also shapes how members of the discipline think and approach their work. As a physics teacher, often our attempt is that how you can train, like how you can you can train our students to understand this disciplinary world better and move them towards the expertise in that discipline. So this this expertise is could be in the content domain, but it could also be in the practice or skill. And moreover, through physics instruction, what we are really doing is we are aiming to support how students can develop their disciplinary identities. So, which is again an attribute that kind of symbolizes combinedly how students feel confident to contribute in physics. What are they feeling belonged to that discipline, and their persistence within that discipline. So basically, the studies in physics education research have reported various things in which you can influence students' STEM identities, or in particular disciplinary identities such as physics identity, chemistry identity. And a lot of research in discipline-based education research kind of have talked about like what kind of activities will make these disciplinary identities more enhanced in undergraduate students or amongst children who are learning sciences in school. And but what has not been done much is what kind of practices of teachers or instructional practices can contribute in the development of physics identity. So that is where like pedagogic practices like responsive teaching basically comes to play. And why this is contextually relevant, and particularly we are a big group of physics educators catering to a large population of students interested in physics in India, then what we really need to think about is there are many activities, or there is some sort of liberty or some sort of flexibility that now that we have in school level or at college level systems, where we can establish more interactional spaces for students. Yet it cannot be denied that teachers still play a significant part or in setting up that discourse in our class. And often times our students' interaction about the content matter that happens in our class kind of is largely with teachers. So you ask questions, you probe them, and probably students are responding. So a great way probably to learn science in our class, no matter how much interactive we make it, still majority of the discourse happens individually with teachers probably. So it is teachers that kind of basically decides what of this discussion can be brought for the larger audience and what probably what can be filtered out. So to know or to enhance the disciplinary identity of students, what kind of educational practices or pedagogic practices are important when we think about this like large umbrella question? I think that we as a physics teachers are very much central to addressing this question, and that is where probably a talk like this would help us to think more and reflect more about our own instructional practices and about what we observe and how as a community all of us can think more deeply about enhancing student physics identities. So sorry for my long introduction, but I think the rest all of the talk is full of examples. So I just took time to give a background about how these examples are connected to responsive teaching. So I will give two examples to start with, which are not from classroom. The first one is in a research setting, and it is a discussion between two two graduates doing some PhD level research in a nanoscience and nanotechnology lab. And I'll give a minute for all of you to probably read it. And it is a discussion between Chiara and Ryan. And after this discussion, Chiara has been interviewed. So she's talking about her experience in the lab related to a particular instrumentation. So if you had a chance to go through the excerpt, what really had happened is Chiara is talking about X-ray photon spectroscopy data. And she's saying that how there's something wrong in this data was only identified by Chiara and was chased further for a long period of time. But how this wrongness in the data or why she felt this data was incorrect has more disciplinary root. So she's using her knowledge of full width half maxima. She's using her knowledge of why there should be two spectrum, there should be two peaks, using some other FTIR notion and understanding that she already has. And she's seeing that the data that she's seeing through X-ray photon spectroscopy, that image or that graph is not making sense to her. I'm not going much into nitty-gritties, but what I wanted to point out in this through this example is there is some even the basis that another chemical bond possibly exists was argued by Chiara based on her knowledge of spin states, full width half maxima, and FTIR. And she brought this specific example to show how physics knowledge was important in her research team to resolve this data conflict, or she was the one who kind of brought this conflict in the first place. And so her disciplinary skill of observing and probably interpreting the data and other associated concepts regarding how you analyze the spectrum were seen as a strength or as a capital for her to do nanoscience and nanotechnology research. Now, what this example basically in physics education research draws your attention to is that the student here is practicing disciplinary agency in a very complex multidisciplinary setting where she is interacting with people who probably may not have that level of exposure to physics and are doing or contributing to research in another domain. But her asset or her strength or her capital was her knowledge of FTIR or of some disciplinary aspects associated with that spectrum, which she could use in order to see what was the issue in that particular data. Now, I'll give you another example because we talked about teaching in teaching in classroom. So this is a very typical example that probably many of you might have done at some level or the other with undergraduate students. And what this example requires or demands from student is basically they physically map this system. So I'll give you again a minute to just internalize a few things present there on the slide. So the students are supposed to write Newton's second law equation for the box position, which is dropped from flight, and they are supposed to physically map the system, do some calculations and ultimately give the position coordinates of where the box that is dropped from aeroplane would land on a boat on water surface. So why this problem is interesting? Because if I ask the students to do this problem in think aloud manner, or be a little bit more vocal about what all they are thinking, there is a great scope to know how the students are approaching, particularly about mapping this entire physical system, like what kind of coordinate system that they are choosing, what equations that they are choosing to write the forces that the object experience in this situation, and how they also go about mathematization of this, like how they see the boundary conditions for this equation, how they go ahead and solve it, and what the ultimate result, is it making any sense to them physically, right? So what I'm again trying to bring your attention is, if in the present case, I'm also thinking, if a teacher has to support student, or if a teacher has to know if the students are doing something wrong or right, what I'm really looking is basically how students have approached this problem. And as I know how they are approaching, I'm really looking for which of these ideas are noteworthy for me to go ahead and ask them or probe them further, so that whatever, whichever stage they are, they will probably complete that particular process or that particular procedure. For instance, if I'm thinking about boundary condition, I would like to see why they have chosen boundary condition as 0 and h, or initial velocity as v0 and final velocity as 0, and how that would lead to the final answer of position coordinate that they are looking at. So in other words, what you're really trying to notice is influenced by how you want them to approach this problem in disciplinary aspect. And if the noticing is always guided by those disciplinary skill that you want them to acquire, and ultimately your instruction can be guided by this knowledge and will help or will support the students at the end. So coming back to the theory, how all of these examples that I'm showing are related to responsive teaching. So in the initial conceptualization of responsive teaching, largely it was done in mathematics domain. It followed a notion that there is a hierarchy in ways students think about any mathematical process. And it is very well mapped with students' learning. So what a responsive teacher essentially has to do is identify which level students are at, and accordingly choose problems or choose instructional strategies to guide the students to reach to the next level of thinking. In contrast to that, in physics discipline, the basis for conceptualizing responsive teaching is that there is a variation in which students are reasoning about a problem. And so there is no set, or there are no limited ways in which students approach or students articulate. And this learning is also seen to be very individualized experience. So why we call it individualized? Because it involves an interplay of what different conceptual understanding that they have, some sort of affective experience, how are they seeing this process, their attitudes, their habits of mind, and their epistemic stances. So all of this together kind of contributes to how are they learning and how are they kind of making sense of that situation. So how we are not juggling between which is a good conceptualization, because both conceptualizations, there is no hierarchy, or both are right at their own places. But PER, or physics education research, particularly thinks that the science problems are so complex that like one particular or only a set of only a few sort of thinking may actually cannot like you may see a larger variation in the ways students are approaching that problem. And oftentimes, when you ask student to elaborate, like how are they thinking about it, you would see that they are not connecting it with some established or like very broad theory, but they are just bringing a very small piece of evidence, very small reasoning to explain why they think that they have moved from this stage of physical mapping to the next stage and so on. So that means, like, if I'm a teacher, if I'm a responsive teacher, I may not need to associate every time like how students are thinking about that larger thing that is driving the universal phenomena, but I'm really thinking about that small nuggets or small ideas that students are bringing with which they are explaining why they have moved from one stage to other. And that knowledge or that information is really helpful for me to decide what should be the next step that as a teacher I should take in order to respond to any facet of thinking that they are bringing to me in classroom. It could be conceptual, it might also be emotional or epistemic in nature, but I'm really trying to see a very little step or incremental step in problem solving at a time, and that will still make my class more sensible and more richer in terms of how physics is being learned in that classroom. So again, like to summarize, I would say that in physics, that means more attention is paid to develop the practice of how to interpret students' ideas in responsive teaching and identify which of them are noteworthy to take it further. So as a teacher, that is a thing that I probably has to internalize. And now I'm going to give you some examples which again have come from directly fresh from the classroom. So I would like to thank particularly Navneeta, Mukul and Shrija from our Vigyan Pratibha team who helped me to bring these examples to you today. So the very first example is from NCERT 11th class, which is about trigonometric functions. So the students are supposed to derive a trigonometric identity of cosine of sum of two angles, cos of x plus y is cos x cos y minus sin x sin y. So the students are thinking about how they can derive this trigonometric identity. So what you see now, the next few slides are going to be about this. So please bear with me. So the students start with this, that they know that they have to derive this trigonometric identity. So the teacher kind of like draws a unit circle on the board and she picks up an arbitrary point P1 and asks the students that shows where the point P1 is and asks the students if they could tell what are the coordinates of P1. And as you could see, there is no response from students. She kind of like continues this and she asks then, okay, are they cos x and sin x? So though she has given the answer, she is not kind of explicitly telling that, and she is posing it as a question rather for students. And she wants the students to verify whether the answer is correct or not. But as you can see, again, there is no response for student. So what you actually see is basically the class is stuck and teacher decides that I need to move on from this situation and do something beyond this. So what happens next, obviously, is like you, as all of us probably would do as immediate rescue is, we ask students to think of if they have come across something like this in their textbook or have they read something in association with that in textbooks, which even the teacher did. So the teacher kind of asked them to go back and read the definition of unit circle and see if that makes a greater sense to them. So she kind of like shows them where it is in the trigonometric function chapters. and hope and now think that like if she again goes back to the drawing that she made, probably the students will be able to say what are the coordinates of point P, which was chosen arbitrarily on a unit circle. Now, again, like for those, I'll give for people who are reading the slides, I would just give a minute to internalize what the unit circle definition is. But what the teacher basically did is, after she asked the students to go through the definition, she went back and chose a point P in the first quadrant, because probably the students were familiar with point P in the first quadrant. And then she again chose the arbitrary angle theta. And she asked, okay, now can they say, can they tell what are the coordinates for point P? To her surprise, like many of them said that this was cos theta and sin theta. So, which makes, so as the student probably are telling the coordinates as cos theta and sin theta, she goes back, and what she does is now she picks again the same position, the same point P, but now she moves it to the second quadrant, which is a new angle, say, let's say new theta. And she asks now, can they, what will be the coordinates for that point? So what you could see probably is the students were okay to say the coordinates were P cos theta, sin theta initially, but they are still hesitant the moment you put the position, the point in the second quadrant. Now, one reason probably the teacher kind of see that the contrast between these two images is because in the first, they're used to see the triangle trigonometry. So perhaps that is the reason why they could find why they could immediately pick up on when you say coordinates of P are cos theta and sin theta. Whereas in the second, they are juggling with it because they cannot immediately do a triangle trigonometry in this position here. And probably that is the reason why they are this contrast kind of helped her to think that the student, like why the student probably are juggling. But being responsive, she doesn't want to give the answer immediately. So she made the students to think about it and come back on next day. And when the students arrived next day, the problem continued. They are still in the mode of deriving this trigonometric, the trigonometric identity. But this time, when she asked, like, what are the coordinates of point P, again, point P in the second quadrant, one of the students mentioned that this is cos x and sin x. There's a change within their thinking over a day. So she was obviously curious and asked, like, why do you think so? Or can you elaborate on that? And the student pointed out again at a triangle. Now, this time, the student has seen the angle x and has managed to show 180 minus x angle, and mentioned that the coordinates are cos x and sin x, because cos of 180 minus x is or sine of 180 minus x is sin x. So the y coordinate therefore is sin x. So what you could see basically is happening is, again, I mean, the teacher immediately pointed, okay, we cannot use it as it is because this is a byproduct of the identity that you are asked to prove. So in the NCERT textbook, students start with this cos of x plus y trigonometric identity, and then they use special angles of 180 special angle to prove how sine of 180 minus x is equal to sine x. So essentially, you cannot use a byproduct, or you cannot use what she means by a byproduct is a special case of the trigonometric identity that they are supposed to prove. So you cannot use that to go back and prove the original or the core trigonometric identity. So what you see is here basically is that the discussion is not pointing out the error in the thought process, but what the teacher is saying that in this particular case, you cannot use sine of 180 minus x equal to sine x property, because in the textbooks you have already derived it from the trigonometric identity that I have asked you to prove. So you cannot actually use the same logic, or you cannot use that to prove the core property back again. But having said that, if there are any other alternate ways, probably with which student had actually come or derived this property of sine of 180 minus x is sine x, then there was a possibility that they could have used actually this just to show what are the position coordinate at this point. So what I'm trying to say is, or show is that the causal story, like why the student cannot use the byproduct or the product of a property to derive the original property, is the message that the teacher wants to convey to students at this point. So it is not like a wrong choice. It is a wrong choice in the context of the problem that they are trying to solve. So what again I would like to highlight in this example is basically how student, very simple or trivial looking thing of identifying position coordinate on unit circle is probably not parsed immediately by the student, and it rather surfaces even different ways how students are thinking probably in order to reach to this position coordinates, and clearly they're not using unit circle to do this whole exercise. Last but not the least, again, this is a so after they did some sine and cosine of x plus y identities, then they are asked to go to some more properties and come back and write down what is the formula for cot of x plus y. At this time, again, now this is very simple, trivial looking example. The student has written cot of x plus y is cot x cot y minus 1 divided by cot of x plus cot of y. And another student immediately says that this is not the same, because the denominator in whatever NCERT textbook form, the denominator in the form has cot y plus cot x in the formula that is like in the printed textbooks. So what is happening here is, obviously the teacher kind of got interested in asking like why is cot of cot x plus cot y is it not equal to cot y plus cot x? But she really decided to probe it further, and she asked like, aren't they the same? And the students actually said that they are not the same, which really makes you to think about like why are students thinking that these the denominator is different, and why, which is cot x plus cot y is not equal to cot y plus cot x. And when you probe it further, only then the teacher realized that the student just the other day had proved or had shown that sine of mx is not equal to m sine x. So definitely what they are thinking it, not all of the algorithmic properties or identities holds good for the trigonometric function. And that is a thought with which they are going ahead. And in that scenario, they are thinking that probably cot x, we should not take it for granted that cot x plus cot y is equal to cot y plus cot x. So again, why this example is important in terms of responsive teaching is because teacher is just, she just doesn't want them to believe her, but rather think why, like, why this property, why the denominator probably is not the same, and to come up with a logical reasoning and use that discourse probably to make make the entire class think about that which of these commutative properties holds good, of algebraic properties also hold good for trigonometric functions, and which doesn't. So though very trivial looking thing, though very simple statement that is made by the student, the refute by student was stronger, and that is the thing that the teacher has sensed, and she decided to look for a causal story, like why the students are refuting. And doing that was basically timely needed by the teacher at this point. So both these examples were from mathematics. What I haven't talked much about, but I would love people to think simultaneously, is a little bit related to cultural part of it. A lot of times students, when we try to teach trigonometry, or when we try to teach physics, we bring some alienated concept, or we bring the problems which are very much posed in the context that we probably do not associate very quickly. Just to give an example, I all throughout my life remember Zener diode has a phenomena of avalanche, and I mean, we come from a flat land, a plateau, and I had no idea what an avalanche of snow would look like, or what an avalanche for that matter is. So I really cannot associate with that sudden, like the breakdown leads to a sudden or immense release of electrons was something that I could see probably in the diagram, but how this is related to avalanche, I couldn't associate, just because culturally I'm not like relating that phenomena with the word that probably I have come across. And there are several examples like this that you come across in physics and in many other contexts. So what I'm again trying to tell is, oftentimes responsive teaching, though it is talked about like disciplinary practices, disciplinary skills, a lot of times students are maybe struggling with like how I'm going to make a sense of the problem that is in my hand, and probably not the struggle is not necessarily of mathematical process or physical mapping or any other thing. So these things may look trivial, but if just helping them to contextualize it, that's something that they relate to, may also help them more in sort of looking at it in a responsive way. So coming back now, how all these things we try, like, I mean, much of this, what I have shown, of course, has a strong theoretical basis. And also like the examples that you saw were taken from classrooms. So you totally see that there is a great potential of teachers' responsiveness playing or making a lot of difference in the way the instruction in classroom happen. But I would also show how this responsive pedagogy or responsive practice was kind of picked up as one of the fundamental pillar or a foundation in which Vigyan Pratibha program that we run at HBCSE, and at which is actually a national level program. Like how this responsive pedagogies kind of became an integral part of our thinking. So what the program has many facets. So a lot of the discussion in the program with students and teachers happen through resource materials that we generate, which are in form of learning units or activities designed for students, where which students do as in class or out of class, but these are a little bit flexible times that are offered by teacher communities and school systems, where teachers facilitate these units for students, and students try out many activities given in that learning unit. In the design of it, we have also cared about that. It is a teacher community who is taking these units to the students. So we also try to orient teachers, like once in a while, the teachers come to different regional centers associated with Vigyan Pratibha, and they get some sort of orientation about how the genesis of this learning unit was, what we have been thinking about when these units were like how they have taken the shape that what you see as a final product, and how do we think probably would be some of the ways that the teachers can think about in order to facilitate those units. So it is not like there is no ideal or one way, but we kind of are really orienting them with the philosophy, with the genesis, and with some possibilities that they can consider in order to facilitate that unit with the with school communities. And what I'm going to do again now is like bringing all these things that we talked about responsive teaching in various different aspects to something which is which went into the design of program. So when we started thinking about how a good how we can make Vigyan Pratibha more richer in terms of responsive pedagogy for teachers and students, we thought about how like giving them an opportunity or chance to reflect on their own teaching practice. So we decided to bring many of these anecdotes, which in fact I presented just now, to teachers and see like how they take these anecdotes and what is their learning about what is happening in class, and if they could share it with the broader community. We also engaged teachers as learners. So if we ourselves particularly take that experience, how it may will that help us to know how students must be thinking while doing that particular learning activity. And we also decided that because it is a community exercise, it is a community build, a community of practice building exercise, then can we make teachers to, can we allow or can we increase the opportunities of teachers to interact with fellow teachers as well as with researchers and other experts in the discipline, and that whole repertoire of experiences may help them to go back and try out some more responsive, to go back in their class with a greater responsive attitude. So many of these facets basically were carefully thought in Vigyan Pratibha program, and we saw how they can help in structuring or in the design of the each of these facet better. So what I mean, in interest of time, what I could do is I probably would just show you 2 or 3 learning unit examples and see how probably responsiveness was embedded or was brought as a thought process in this situation. So one of the, and again, I mean, the entire learning unit is a 3 to 4 classroom session activity. So you get several such instances of student-teacher interaction. But I have just picked only a few to make my point about responsiveness here. One of the learning unit is about counting areas, which essentially gives the practice which allows the students to calculate area of different polygons and find out its relation with the boundary points and the interior points. What I mean by boundary and interior points is you could see the figure has a grid and there are several 2 different polygons drawn at the moment. So the task progresses with students calculating area of each polygon, and there are several such sets. And in each time, after they alongside they determine the area of that polygon, they also look for what are the how many points are there on the boundary or on the edge of the diagram, as well as how many points are there in the interior of the diagram, and is there a mathematical relation which kind of like binds area with these points. So what essentially is what I'm presenting is basically task 1, which is almost a 0th level activity that they start this learning unit, where the teacher has asked student to draw what is to calculate what is the area of figure 4. Okay, and what you see basically is they probably have guessed the figure 4, the rectangle part area quickly, and the teacher has already done, teacher has already calculated what is the area of the vertical triangle. So you could see that the teacher has given the height as 5 units, the base, the base is 5 units and the height is 1 unit. And she applies the area formula as 1/2 BH and gives the answer as 7.5 unit square as the area of the triangle. But somehow again, here the student doesn't seem to be convinced with the area of triangle as 7.5. Now, this probably would look very trivial to somebody who is looking at it. And this is also task, like 0th level task for students. But it is interesting in responsiveness point of view or in epistemic point of view that why the student is not happy with the answer of area 7.5. So when dig deeper, you would see that the teacher, when gives the answer and asks the students to confirm and check, the student is saying that, well, you said in this triangle, the area is 1/2 BH, but how can you consider 1/2 BH? It is not a right angle triangle. So you would notice that the teacher kind of has anticipated that someone might ask this question because there are several disciplinary naive ideas in it which are hidden. The student basically, first is about visualization. The student cannot see this as a right angle triangle, which is something that a lot of, I'll just go to the next slide, which also has the image, but what the student is really finding it hard that they cannot see the base along horizontal line. And a lot of time, most of the school level geometry kind of begins whenever you are asked to draw a triangle. Most of the time, student by default choose the bases along a horizontal x-axis or parallel to it, max. But what you see here is another student kind of comes to rescue and says that, okay, if you, let's say, tilt the paper and look at it, then this, like the tilt makes the base horizontal, which is something that they are used to. And then she says that with that, probably the problem is solved. Now, the teacher kind of have noticed many things. That it is not just the problem of probably tilt because, but the teacher kind of agreed to whatever explanation S2 has, the another student has brought in terms of tilt to make it like to make the base horizontal. But in addition to that, the teacher also noticed that the student has is not accepting the formula of area as 1/2 BH because the student think that this is not a right angle triangle. So there is added responsibility just from this naive, like from this statement, that the teacher could see that students first of all are struggling with finding relating this formula to area of any triangle, and then how this could be done without just saying that this formula holds good for any like any triangle, the area is 1/2 BH. So what the teacher kind of brings in is a situation where the teacher says that in a triangle, height can be anywhere. What she meant is, if I choose an obtuse angle or an acute angle, I can still drop a perpendicular and see and measure the height, but the height probably may not always appear inside the triangle. This is what she meant. And she also then further kind of asked the students to commit if they are still okay with area being 7.5. So she has kind of thought about like what all things the students are reasoning in order to say that this is the area is not 7.5, which holds much beyond just visual flip of it, but it is also related to they not accepting this for any other triangle. And the teacher basically uses this chance to make that more explicit for students. So again, this is a very very simple or could have been a temporary fix, but the teacher kind of looked into disciplinary aspect, what the students are really thinking, or what is the thought process which is making them to resist that the area is not 7.5. And then she chose to like probe it, or she chose to bring the question that was surfaced by a student and continued the discussion for a little longer. Now, another example which is interesting again in physics domain comes from another learning unit of pinhole camera. This unit is interesting because students are familiar with developing the device with with the structure, but what they haven't seen is probably that it also can be used as a measuring device. So you can actually calculate height of an object using a pinhole camera, and the learning unit really navigates them to come or to learn that measurement skill in a through the device. Why this is interesting again in terms of responsive teaching is if you could notice that the student has managed to develop create the pinhole camera and also has measured the length of a pole probably, and the pole length apparently is 180 centimeter. So the conversation here really is the student is saying that height of the pole is 180 centimeter, and then immediately another student is saying that there is something wrong or fishy, because I mean your height itself is 150 and the pole looks at least 4 or 5 times taller than your height. So there is something again wrong. So what I'm again trying to show here is student have really critically thought about, like they may have managed to do may have managed to see how these are similar triangles and how the formula would work, and they are able to calculate the object length. What they probably did mathematically doesn't make sense to them when they compare it with their own height, or and that had led this discussion even further. So the problem with the data was identified by the student, and that is a nugget that the teacher picked, and she continued about how students are really can be probed to think is the measurement that they have done is making sense to them or not. So again, how this can be responsive. So when we brought this anecdote in classroom, that happened in the classroom with the community of teachers, and asked them, like, what do you think about this example? What must have happened? Then one of the teachers said that I can see that the student is doing some sort of critical thinking about estimation, but that also invoked an idea amongst the teacher community. And she said that when I do this learning unit next time, what I'm probably going to do is maybe ask the students to different groups to measure different things and then compare like what are their observations. So even a little problem investigation or error investigation done by the student has helped the teacher to come up with that idea and probably use it or use it with an added sense for the larger group of audience who can be benefited by that small error estimation problem that a different group worked out. So again, why this is relevance is because one of the ways responsive practice is cultivated amongst teachers is by sharing whatever the takeaways that they with the community or reflecting on what has happened in the classroom. And this is an example which shows that teachers kind of have reflected on this anecdote and decided how their instructional practice can be rearranged in order to bring such examples which are like brought by the students in like when they do this activity for the next time. So the last example, and then I think I will start wrapping up, which I wanted to give was from another learning unit of will it sink or float. And what this, so again, this is not this is a refurbished idea, but one of the studies published in American Journal of Physics had suggested that students still, even at UG level or beyond, still struggle with seeing the concept of mass and volume and how they affect how they are related to buoyancy. And one of the ways in the paper had suggested that the student should be able to come up with different rules or come up with different conjectures that they can check in terms of like which variable probably is responsible for sinking and floating. And this is what precisely has been actually tried out in the learning unit. So what we did alongside is we started the learning unit with several questions, and each of the question could be posed along with some sort of counter. So oftentimes, like when you ask students to think, why do you think that a large piece of block, I mean, what will sink or float, a large piece of block or a tiny stone? The student may say that the block will sink because it is really big. And so what they're really thinking is they're connecting the bigger part of the object to sinking or floating. And obvious probe is like, so do you think that it is the size that affects basically sinking or floating? And if that is the case, then you also have a counter that, well, what happens when you see a small metallic screw which still sinks, whereas a larger wooden block can still manage to float. A follow-up of it. So there are several questions basically when the student, which challenges basically, or which makes the student to think hard and provide a good warrant for why they are thinking about it. So we might ask another question about like, let's say the student say something as the ship float because it is stronger and big, but if you put a small and heavy object in water, it will sink. So basically what they are relating is ship sinking is related to weight probably. So you would counter them with a question that if weight is the only reason why something sinks or float, then how can you explain the ship, which is like very huge in terms of weight, still manages to float? So you're really presenting various, like you're giving them a challenge to think about like why this is happening. And you're also trying to give asking them to present a warrant, or asking them to tell what is the causal story, why they think that this is happening. And with the counter, you are kind of making them to think that whatever they said, does that make sense now after another counter is brought in the picture? And this can happen, or we can go ahead with this, like how large ship floats. Probably we can present another counter about where typically the student think that all metal object will sink because metal is really heavy. And in that case, you can again try and give a counter that what happens if I take a same metallic ball, but probably change its shape, what is happening. So they are made to think at multiple level about different variables that can independently and simultaneously act and are responsible for floating or sinking of the object. Now, after they do all of this thinking in terms of counters that they are brought, then they are asked to think about now how would they actually experimentally test it. And the result is that, like as you could see, they come up with several set of tasks where they try and test one variable at a time. So they see how the objects of varying weights but fixed volume has what tendency it has, what happens when you fix the weight but vary the volume, what happens if you choose different liquids in which, and see whether the object would sink or float. So this series of tasks are done after the brainstorming about the possible variables that they think is affecting sinking or floating. And they are kind of with the counters and with more explanation. Then when the students come up with or are shown these variety of tasks, towards the end, probably they come to an understanding that what is really making some object to float or some object to sink. And they should be able to say that it is it has to do something with the average density of the object and the density of the liquid in which they are immersed. And if the average density is lower, then the density of the liquid, what will happen, and the other way around. But unless they play with independent variables or with combination of these variables in mind as a theoretic, as a thought experiment, then only then the students are encouraged to then see how these variables in reality actually has an effect independently and in combination on sinking and floating. And they reach to an understanding of what probably is driving the causal reason for something floating or something probably sinking in the water. So what with probably bringing examples from high school, from college, and a little bit from undergraduate, what I really tried to show that many of these examples kind of first of all are telling you that students do have some productive intuitions which they present time to time when probed, and a teacher can really tap to that. In case of area of the triangle, you could see that student's query was thought interesting to parse, and the disciplinary connection was revived by the teacher. There are many other examples which I have already shown how they are connected with the disciplinary skill that the teacher expect them to learn, but probably they are making a small and incremental step towards this. So what many of these also had some pre-identified positions or by teachers where they thought that it is interesting or worth spending some time and asking the students what they are thinking. But some of them, as you could see, were also on the fly or in that instant where teachers managed to notice that this has definitely some sort of a disciplinary connection or some sort of substance in the student's reasoning is associated with the disciplinary knowledge, and therefore that was picked up by the instructor. And lastly, I also feel that by bringing students data, by making them to come up with their own model, generate the data, is also making them is also extending the opportunities for doing science or working on their own data, which kind of brings more agentic attitude in student to while they carry out certain things in the discipline. I started with a point that the students has a variety of ways of thinking the problem. So I would end up also with that note. The last task that we do with teachers is we ask them to do some sort of open-ended problems. So one of this is shown here where they are supposed to make an open box with this graph paper and tell where what is the corresponding height for the box which has a highest volume. So what you could see is, again, as I pointed out in many of the previous examples and also in repeat and mentioned and emphasized in the theory, a student can approach this problem in multiple ways. Some may actually cut pieces, corner pieces, and create an open box of different heights and note down the volume, and they would see that where probably the volume is highest and note the corresponding height. Some may actually see the problem and see that this is basically a differential equation that I can solve, and I can just probably test, I can basically pick up the maxima and minima condition and use that to solve the problem, and that will still give me what is the corresponding height for which the volume is highest. So what I'm trying to make you think in this problem is, as a responsive teacher, probably we should allow all of these ideas to emerge in the class. But depending on what students decide, or what is the understanding that students bring in order to solve that problem, your instructional strategies should have some scope to incorporate these ideas. Now, I know that responsive teaching, like theoretically and practically, may look far different, but what I really could show with even a little set of examples today was a lot of times we see that there is a great way, or there is a potential in exploring students' ideas, and it is not very westernized. It, like, you could see all of this happening in very much in our classrooms. So I would conclude that there is definitely a need of responsive teaching, as you could see. But we also see that the students' can be explored right in time, and they do provide more sense to them about how they are learning that particular concept. So if we have a chance to convert the discussion that arose either from their refutes, from their problems, or from something that they say in the class, and take it to more productive framing, then that is something worth experimenting. And it is true that, like, fast-paced classes may have some challenge, undergraduate courses may have some challenge to adapt this methodology. But having said that, you can also see that in small little efforts definitely have been successful, or can show that this is something workable even in our classroom. So with that note, I think if you are more interested in knowing some similar anecdotes from other learning units that I haven't covered here, or in general seeing how, like, what are these learning units are about, then I think we can have this discussion at some point. But I feel that responsive teaching is a pedagogy that is worth giving a try, and definitely it needs more preparation from teachers' end. But I think it is, like, definitely good to go and worth trying it in the classroom that you are presently teaching. So I thank everyone for listening patiently to me so far. And now I think I would love to hear any feedback or comments from the audience. So thank you very much.
Thank you, Dr. Deepa. Yeah, it was a wonderful talk. And any questions, audience, if any question is there?
How to motivate the faculty?
Well,
good question.
That is a great question. And I think there are, I mean, I already see the motivation. Otherwise, many of you wouldn't have come to the talk. So that there is an intrinsic motivation to be a responsive teacher. So I think you scored some points there already. But I mean, as I said that I totally see the chaos involved in this process, which many researchers have also pointed out. But we also see the value in the process, and the value that it adds in terms of students' identity building. So I feel that definitely not for the entire curricula, but for some concepts, particularly when you're teaching, there is a lot of research about concept of energy and how in responsive way this can be taught in high school. Concept of motion probably is most researched in the responsive teaching space. So there are some definitely school level ideas are much more parsed in with the responsive pedagogies, but and there is a rich literature also in mathematics about it. So maybe a good way to start is to see probably how our fellow community members have adopted this methodological aspect in their teaching at different level, and maybe that might also encourage. But I can see also it is not like a one-day thing or a one-day miracle. So there is like the scholarship needs to be built, and it will take time, and it would need more closed interactions with students, then only we know basically how to prepare ourselves for the upcoming batches. So I think a good way to start would be to just give students some problems and let's see or hear them out, and from use that knowledge repertoire to start thinking in that direction.
So any other question? Do we have any other question from anyone?
Deepa, there was one question which was coming to my mind.
Mm-hmm.
That was it that now national education policy is coming. And when you look at the national curriculum frameworks,
Mm-hmm.
whether it is of schools or it is of colleges,
Mm-hmm.
do you think that there is a possibility of now these kinds of strategies being adopted or adapted by the teachers in the classroom itself?
Mm-hmm.
Do you
Well,
see that kind of a signal, possibility?
yeah, well, I mean, there are, of course, a lot of it is said in terms of jargon words already in many like recent national education policies. I think what right from NCF to 2004 and 5 until now, what we have been seeing is a recurrent need to see how our classrooms can be made more and more interactive. But when we call it as to make it more interactive for students, we are like what we are really gaining from that is we are not utilizing or that to a greater extent. If we let the students talk about different problems, do some open-ended things, do some activities, what we are really which has been attempted to a great extent, I would say. But what we really learn from it and how the teachers can take it forward in order to probably update their day-to-day instruction, has that part I think has not talked much about, and there is a much guidance or like thought being conveyed about how that can be done more productively. So somewhere I feel that the responsive teaching fits in the domain where you are really trying to see how, as a professional, as a teacher, how my own professional development in the professional development, what I really need to learn in order to see how I can contribute as a better teacher. And when you focus or when you make these practices more obvious in professional development program for teachers to allow them to reflect more, to allow them to even see and identify from some set of examples, if they could see this how can they analyze something that they from the students ideas. Those are the practices which really need to be cultivated at the level of teacher professional development program, and much of that is disciplinary, has a disciplinary association. It is not like probably some may cut across the discipline, but some are more specific to that discipline. And I think a lot of the work that I feel that can directly contribute into this national education policy in the domain of professional development of teachers actually is where I see this whole talk or the spectrum of things that we do would fit in well, in my opinion.
Yeah.
Secondly, there was one thing more in it. Responsive learning and active learning, is there any distinction between these two, or they are the same thing? And when we say responsive on the part of the teacher or on the part of the students?
Okay, and what was the other one? Sorry, I couldn't hear clearly.
I said between active learning and responsive learning. Are they same thing or there is a difference?
All right.
What is the subtle difference between the two?
So active learning is more of a, how I envision is responsive teaching, though centralizes the ideas that students, surfacing students' ideas are important. it doesn't eliminate necessarily the teacher's role in that whole process, because the teacher also kind of like probably is an equal player in this whole scenario, but the instruction probably is more flexible and needs to be adopted more needs to be changed based on what like students are bringing. And active learning really is probably a more methodological or operationalized way of how you can make students to think about a problem or think about an activity and bring more ideas that they are thinking about it on the surface. So I see the active learning also like it is more so both of them are central to students' ideas, but responsive teaching kind of doesn't put the instructor or teacher as an independent entity, but there is an equal load bearing from both students as well as teachers. But I think that is what I see, certainly the difference between these two. Yeah. Having said that, I would also see that active learning also can be made great and efficiently if the teacher kind of like creates a structure or a design for it. So there is a lot to do about how you envision or how you plan these activities and run it. So the planning or that structural aspect is important equally in both sides. But the responsiveness that I talked about kind of cared more about the disciplinary connections of it in particular. Yeah.
Okay, thank you.
I have a question. See, this pedagogy of responsive learning or teaching, probably you are trying to reach out to teachers through your Vigyan Pratibha program, right? And the percentage of teachers that this program the attending must be very small actually. So is HBCSC trying to reach out to more and more teachers so that this kind of pedagogy is reaching to them? Because this is a very important thing which I have learned today, that how it is important in the teaching, etc. So what are the efforts that other than Vigyan Pratibha you people are making?
So I would rephrase it because though Vigyan Pratibha, like the orientation for teacher is for limited teachers, and of course, I mean, it is a small fraction compared to the huge numbers of high school teachers that we have presently in the nation. But the resources that we have developed within Vigyan Pratibha are open source. So all the teachers, I mean, anytime both students as well as teachers have a free access to it. Teachers need a special login because there are also additional notes developed for teacher for each of the learning unit, where some more ideas and briefs about which are the interesting questions that can be passed more in detail are given. There are limited workshop opportunities per se for teachers at HBCC or at other regional centers. Limited is not like very limited, but I think still limited in compared to the entire high school spectrum of teachers. But we also have started working with state government schools and are reaching and doing these workshops. But our model itself is essentially that these teachers particularly take these units for students. So with or without actually doing an orientation at our centers, the teachers always have a free access to this. We also do some online discussion sessions which is open for all teachers, and where the teachers community can come and listen about a particular learning unit and the ways probably these learning units are designed, and can try it out with their students. So most of the, other than the workshop participation, most of other facets of the program are are in public domain and can be readily used. We have also made some bilingual versions of learning units. So they are available in more than 4 or 5 regional languages, Marathi, Tamil, some are available also in Gujarati, in I think a few more languages, Hindi. Students from even state government colleges where the mode of instruction of science and mathematics is Hindi, Marathi, Tamil, they can also take a look at it. And this work is like in progress. So we really wanted more volunteers who could help us in creating more bilingual versions of various Vigyan Pratibha learning units. And but at present, at high school level, that is a larger program. And probably a unique program at HBCSE. And most other programs kind of tap at a different level of population of teachers as well as students. But Vigyan Pratibha is more focused or designed intrinsically to start to focus more on high school students and teachers community who like teach science and mathematics at high school level. So even more specifically, it is for 8th, 9th standard students, but we have seen that these units have been flexibly tried by teachers at a little bit lower and higher levels.
Thank you. The main problem generally teachers would be saying is the time factor. And you have also mentioned that it requires elaborate time, but it is worth definitely. And as Professor Ahluwalia has raised this query, NEP, whether it will allow. So we are hopeful that probably this NEP will, in the domain of professional development, will allow them to take up such things. And we are really hopeful.
I think it is already recognized, and we do several workshops.
So I think it is quite possible that we can reach out to more and more teachers with this kind of a pedagogy in teaching. Okay.
Yes.
Thank you so much, Deepa. It was really a nice talk, and I think it was a really, I think a teacher must know about all these small things and the new pedagogies. If there are any chats, let us see. No, they are saying that it is thank you, nice talk, very nice talk. Punita Verma, Neha Katoch, Minakshi Sayal, they have just appreciated. I don't know how it is just coming to me, I think, host.
Yeah.
So there is no question. I checked on the YouTube as well, and we have no question as such. So over to you, Sapna, if you can.
Yeah, thank you, ma'am Rekha. Thank you, Dr. Deepa. It was wonderful talk, and I think now there's a time now. Many thanks to IAPT. I've got a message from Baba Sutar. So Deepa, everyone is appreciating the talk. So I think it was very nice, and we've gotten an idea, and hopefully some of us will definitely implement it in our classroom. So thank you very much to you for your sparing your valuable time and being with us. And I hope we'll meet again in our some other next event. So once again, thank you very much to Deepa Chari, Ma'am Rekha, and everyone who has joined. Thank you, Professor Ahluwalia, for joining us. So with this, we come to the end of this session. Thank you, everyone.
Yeah, thank you everyone, and we look forward for such more sessions with IAPT, Deepa.
Yes.
Yeah, definitely.
Thank you.
Thank you. And with this, we conclude. Yeah, we conclude this session. Thanks a lot.